This video series is to accompany the Cisco Netacad Switching, Routing, and Wireless Essentials course. This video covers Module 13, Wireless LAN Configuration. In this video, we're going to look at 4 objectives: remote site wireless LAN configuration, configuring a basic wireless LAN on the wireless LAN controller, configuring a WPA2 Enterprise wireless LAN on the WLC, and troubleshooting WLAN issues. 13.1 Remote Site Wireless LAN Configuration. Remote workers, small branch offices, and home networks or SOHOs often use a small office and home router. These integrated routers typically include a switch for wired clients, a port for the internet connection, sometimes labeled WAN, and wireless components for wireless client access. These wireless routers typically provide wireless LAN security, DHCP services, integrated name address translation or NAT, quality of service, as well as a variety of other features. And the feature set will vary based on the router model and router manufacturer. And there's a note here that cable or DSL modem configuration is usually done by the service provider, either on site or remotely. Most wireless routers are pre-configured to be connected to the network and provide services. Wireless router default IP addresses, usernames, and passwords can easily be found on the internet, and that's the default. Usually it's admin or something along those lines. And so your first priority should be to change the defaults for security reasons before you put those routers into the mix. Before you even connect them to the internet, you want to make sure that you change the default passwords and usernames for the administrators. So you want to gain access to the wireless router's configuration GUI. You open a web browser. Well, first you want to connect to the router, either wireless or I usually connect through an Ethernet cable. And you enter the default IP address for the wireless router. The default IP address can be found in the documentation that came with the wireless router, sometimes on the cover or on the case, but usually it's in the paperwork. Or you can look up the model on the internet and find the default IP address. The word admin is usually or commonly used as the default username and password. And again, that's the reason you want to change that password before you do anything else. Now, the basic network setup includes the following steps. You log into the router from the web browser, change the default administrative password, then restart it or re-log in with the new administrative password. Change your default DHCP v4 addresses, renew the IP addresses, and then log into the router with the new IP address. You also want to view the wireless LAN defaults. You can change the network mode, identify which 802.11 standard is going to be implemented, then configure or change the SSID, configure the channel, ensure that there's no overlapping channels in use already so that you're not going to get any type of interference, configure the security mode, selecting from Open, WPA, WPA2 Personal, WPA2 Enterprise, and then configure the passphrase as required for the selected security mode. In a SOHO, or small office home network, or small office home office, one wireless router may be enough to provide wireless access to all the clients. If you want to extend the range beyond about 45 meters indoors and 90 meters outdoor, you need to create a wireless mesh network. And to create a mesh, you add other access points with the same settings, except you use different channels to prevent interference. So you can extend a wireless LAN in a small office or home office, and it's become a lot easier. You can buy mesh network devices and put in, so you just set up one device, and then you have the extenders that you put in other locations that extend out the mesh. Manufacturers have created wireless mesh networks, simple through smartphone apps as well. Network address translation, or NAT, for IPv4. Usually the wireless router is assigned a publicly routable address by the ISP, and it uses a private network address for addressing on the LAN. So to allow hosts on the LAN to communicate with the outside world, the router will use a process called NAT, or Network Address Translation. NAT translates a private or local IPv4 address to a public global address, and the process is reversed for incoming packets. Now, NAT makes sharing one public v4 address possible by tracking the source port numbers for every session established by a device. And if your ISP has v6 enabled, you'll see a unique v6 address for each device. Quality of service, or QoS. By configuring QoS, you can guarantee that certain traffic types, such as voice and video, are prioritized over the traffic that's not as time sensitive, such as like an email or file sharing. And on some wireless routers, traffic can be prioritized on specific ports. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of the LAN. However, there are situations where specific ports must be opened so that certain programs and applications can communicate with devices on different networks. Port forwarding is a rule-based method of directing traffic between devices on separate networks. Port triggering allows the router to temporarily forward data through inbound ports to a specific device. And then you can use port triggering to forward data to your computer only when a designated port range is used to make an outbound request. 13.2. Configure a basic wireless LAN on the wireless LAN controller. So a wireless LAN controller topology, you have the access point. It's a controller-based AP as opposed to an autonomous AP. So it requires no initial configuration, and it's often called a lightweight AP or an LAP. LAPs use the lightweight access point protocol to communicate with the wireless LAN controller. Controller-based APs are useful in situations where many or a lot of APs are required in the network, and as more APs are added, each AP is automatically configured and managed by the wireless LAN controller, much like you would have a college campus and you've got, let's say, 4 stories to a building, or maybe you've got multiple buildings on the same campus, and you can configure APs across the campus, but you use a wireless LAN controller to control the information across all of them. Configuring a wireless LAN controller is not that much different from configuring a wireless router. The WLC controls APs and provides more services and management capabilities. The user logs into the WLC using credentials that were configured during the initial setup. And the network summary page is a dashboard that provides a quick overview of configured wireless networks, associated access points, and active clients. And you can also see the number of rogue access points and clients that are attached as well, if there are any. You can then click Access Points from the left menu to view an overall picture of the AP system's information. This one's using 192.168.200.3. And then because this is using Cisco Discovery Protocol, it is active on this network, and so the controller knows that the AP is connected to the Fast Ethernet 01 on that particular switch. And the AP in the topology is a Cisco AeroNet 1815i, which means you can use the command line and a limited set of familiar iOS commands. Now, most controllers will come with some basic settings and menus that users can quickly access and implement a variety of common configurations. However, as an administrator, you'll typically access the advanced settings. So this example here for a 3504 wireless controller, you click Advanced in the upper right-hand summary corner, then go to Advanced Summary page, and from there you can access all the features of the controller. Wireless LAN controllers have layer 2 switch ports and virtual interfaces that are created in software, and they're very similar to VLAN interfaces. So each physical port can support a lot of different APs and wireless LANs, and the ports on the WLC are essentially trunk ports that can carry traffic from multiple VLANs to a switch for distribution to multiple APs, and then each AP can support multiple wireless LANs. Now, basic wireless LAN configuration on the controller includes creating the wireless LAN, applying and enabling the wireless LAN, selecting the interface, securing it, verifying that it's operational, then monitoring it, and then viewing the wireless client information. So we create the wireless LAN, and in the figure to the right, we set the SSID to wireless_LAN right here, and then we apply and enable the wireless LAN right here. Step 3, we select the interface, and that will carry the wireless traffic. Next, we secure the wireless LAN. Step 5, we verify the wireless LAN is operational. Then we monitor the wireless LAN to look at any advanced summary page and confirm that the wireless LAN now has one client using its services. And finally, on step 7, we view the wireless client the client information. We can look at the MAC address, the IP address, and of course there's the SSID. 13.3, configuring a WPA2 Enterprise wireless LAN on the wireless LAN controller. In this example here, PCA is running Simple Network Management Protocol, or SNMP, and Remote Authentication Dial-In User, Radius, server software. And the network administrator wants the controller to forward all of the SNMP log messages to the SNMP server. And so the administrator wants to use Radius for authentication, authorization, and accounting, and users will enter their username and password credentials that will be verified by the Radius server. And then the Radius server is required for wireless LANs that are using WPA2 Enterprise authentication. And the note here is SNMP, the SNMP server and the radius server configuration is beyond the scope of this module, and we'll cover it a little bit in later modules and then in other classes. So to enable SNMP, we click Management. We then click SNMP. We click Trap Receivers. We click New to configure the new trap receiver. We enter the SNMP community name, the v4 address, and then click Apply. And then the controller will now forward SNMP log messages to the SNMP server. To configure the controller with the radius server information, we click Security, we click Radius, we go to Authentication, we click New, we add PCA as the radius server, and then we enter the v4 address for PCA and the shared secret password that will be used between the controller and the radius server, and then we click Apply. And then after clicking Apply, we configure the radius. The list of configured authentication servers refreshes with the new server listed. Now with VLAN 5 addressing, each wireless LAN configured on the controller needs its own virtual interface. So WLC has 5 physical data ports that can be configured to support multiple wireless LANs and virtual interfaces. And the new wireless LAN will use interface VLAN 5 and the IP address of 192.168.5.0/24. And therefore, router 1 has been configured for VLAN 5 as shown in the topology on the left. And we can do show IP interface brief output to see the information on the right. Now the VLAN interface config on the controller includes the following steps. We create a new interface, configure the VLAN, configure the port, configure the server, apply and confirm, and then verify. So let's take a look at those. We create a new interface, click on Controller Interfaces, click New, configure the VLAN name, and in this example we're going to do VLAN 5, and the VLAN ID is 5, and then it's applied. We configure the port and interface address on the interface edit. We configure the DHCP server address right here, and then we apply and confirm. We then verify our interfaces to make sure they are connected, and the interfaces should show the new VLAN 5 interface, and it should be shown with the IPv4 addresses, or IPv4 address. When we configure the DHCP scope, we create a new scope, we name it, we verify it, we configure it, and enable it, and then we verify it. So on step 1, we create a new DHCP scope. We do internal, DHCP server, DHCP scope, and then new. And then we name it, and in this case, we're going to name it wireless_management. Then we're going to verify it, and we're going to look at our scopes. Then we're going to configure and enable the new DHCP scope on the edit screen for the wireless management scope. And we're going to configure a pool of addresses right here. And then we're going to set the default router. And then we're going to click Enabled and Apply. And finally, we verify the DHCP scope, and we can check to make sure that we're getting the right scope and right address pool that we assigned. By default, all newly created wireless LANs on the controller will use WPA2 with Advanced Encryption Service, or AES. And 802.1x is the default key management protocol used to communicate with the radius server. And so we're going to create a wireless LAN to use interface VLAN 5. And much like the previous steps, we're going to create it, we're going to configure it, we're going to enable it, then we're going to verify, then we configure the radius server, and then we verify the wireless LAN is available. So on the first step, we create a new wireless LAN, go to the wireless LAN tabs, create new, then we configure the name. In this case, we're going to call it, put company name in there. Then we're going to click Enable, and then we're going to do the interface, and in this case, it's VLAN 5. We're going to click Apply and OK. And then we're going to verify AES is set as our encryption, and then we're going to make sure that the key management is 802.1x and that it's enabled. Next, we're going to configure the radius server. We're going to select AAA servers, and then we're going to put the IP address in with the correct port, and then we're going to verify that the new wireless LAN is available, and we should see that information on that screen. Troubleshooting wireless LAN issues. Network problems can be simple or complex, and they can result from a combination of hardware, software, and connectivity issues. As of the recording of this video, I have been dealing with my ISP for about 4 weeks, a network issue that we could not solve. My upload speeds were bouncing all over the place. My download speeds were just fine, They were well over 200 megabits a second. My upload speeds were supposed to be above 20 to 25. They were bouncing between 5 and 10, 15, all over the place intermittently. We couldn't figure it out. So we've done everything from check all of the signal from the pole all the way to the house, from the house inside, replace the router, check the internal routers, checked everything. We're still not sure if it's solved, but sometimes it's just really difficult to find network problems. So we need to analyze from beginning to end, check the simple things first, always check the simple things first, and you need to determine the cause of the error before you start resolving any network issues. And that's what we call troubleshooting. And in the Cisco certification, in the CompTIA certifications, and any certification that you're going to do, and in the real world, outside of certification, troubleshooting is going to be one of the biggest tools that you can have. If you can be a good troubleshooter and solve problems, you are going to be more valuable than most other people. I've always looked for people that are good troubleshooters, because those are the type of people that are going to try to solve things on their own without having to ask questions or have a lot of hand holding. And so learn to be a good troubleshooter, because it's going to do you well in your career. So you should follow a systematic approach though, and make sure you're documenting everything. So a efficient troubleshooting method is based on the scientific method, and it can be broken into 6 main steps. And these 6 main steps, you're going to find out that these are across a lot of different areas. If you go into database creation, if you go into website design and you're troubleshooting anything, you're going to follow these basic 6 steps. The first step is you're going to identify the problem, and that is troubleshooting and find out what's going on. You use a lot of conversation with the user, and you do a lot of just figuring out what's wrong first. And then you establish a theory of probable causes. You try to work from the easy steps first until the more difficult, until you try to figure out what's going on. Then you test your theory to determine if the theory was correct, and then how do you fix it. Then you establish a plan of action to resolve the problem. Make sure that you're not causing more problems by solving the problem that you think you're solving. I worked with a person years ago, and we called that person the Wild West, because they would just start troubleshooting and they wouldn't test theories. They would just start fixing things, and it sometimes would cause a cascade effect and cause other problems. So you always want to make sure that you establish your theory, test your theory, and then have a plan of action to make sure that the changes that you're going to make aren't going to cause other problems. Then, after you have fixed the issue or think you fixed the issue, you want to verify full system functionality. You want to verify with the user, and this is critically important, because you can have you can solve a lot of your frustrations from the users by verifying with the user fully that the problem has been solved. Don't close tickets until you know the user is fully satisfied that the problem is solved. Then you can close the ticket, and then you can document your findings, actions, and outcomes, and then close the ticket. And the reason the documentation process is often overlooked, but it's one of the most important steps, is because if you start having this problem 2 to 3 to 4 weeks down the road, you want to be able to see when you start establishing your theory again that you've got this documented, and you can quickly say, oh yeah, I know what that problem is because I've got documented information about this. One of the common problems is you want to check for no connectivity. You want to check to make sure that the physical Ethernet's plugged in. If you're using Ethernet connection, if you're using wireless, you want to do the IP config to make sure that you've got an IP address. You can use the ping command. You can ping the local 127.0.0.1. Then you ping your gateway. Then you can ping something on the opposite side of the gateway to see if something's working. So if the PC is operational but wireless connection is performing poorly, you can check the following. You can check the plan coverage. You can check the channel settings of the wireless client, or you can check the interface with the 2.4 gigahertz band. I have an app on my smartphone that I can use to check wireless signals, and it will also show me all of the different signals and all the different channel information, and it's fairly easy to scan that and look. Next, you want to ensure that all the devices are actually in place the way they're supposed to. Check physical security issues. Has something changed? Did somebody unplug something at the router area? Do you have power to all your devices? Are they all powered on? Inspect the links between the cable devices to make sure there was any bad connectors. You might have had a mouse come into your area and chew through a wire. You just never know. So you want to check the physical devices are in place. Verify the wiring. You can ping devices to do that, including the access point. If connectivity is still failing, Perhaps something's wrong with the AP and start looking at its configuration. When the user PC is eliminated as a source, then the physical status of the devices is confirmed. You can start investigating the performance of the access point, check the power status, check the connection into the access point. Then to optimize and increase the bandwidth of 802.11, dual band routers, you can upgrade your wireless client. Make sure maybe you can slow, end devices can slow the entire wireless LAN. So for best performance, all wireless devices should support the same highest acceptable standard. You can split the traffic. You can also look for there's several reasons for using split traffic. The 2.4 gigahertz band can be suitable for basic internet traffic that's not time sensitive, and then 5 gigahertz is for it's less crowded, and it can be used better for streaming multimedia. And the 5 gigahertz band has more channels, therefore the channel chosen is likely interference free. Now by default, dual band routers and APs use the same network name on both the 2.4 and the 5 gigahertz band. It may be useful to segment that traffic out, and the simplest way is to rename one of the wireless routers. I typically will put a name and then I'll put 2.4 or 5 at the end of the name, so that way when I'm looking at them I'll know immediately just by looking at the name of which one is the 2 and which one is the 5. And then to improve the range of the wireless network, ensure the AP is located free of obstructions, furnitures, fixtures, tall appliances. Make sure it's as high up in the building as possible or as high on that floor as possible. Make sure there's no metal, lighting, things like that that could block the signal. Now, most wireless routers also offer up firmware that should be periodically verified. So just like you verify your BIOS on your desktop or your applications on your smartphone, you want to upgrade your firmware on your devices. So you can do that by logging into the controller and then checking the, for example, here on the right, the Cisco 3504, and then you can download the latest upgrade and upgrade it, or check to see if you've got the latest one, and that sometimes will solve problems as well. So what did we learn in this module? Hopefully you learned a little bit, and we learned about wireless LAN configuration, and this is screen 1, and you can pause your video here to read these. This is screen 2, and you can pause your video here to read these as well, and I hope this video was helpful for you.